Okay, formula mass. This is the mass, the average mass of an individual molecule or formula unit. You look at the formula for the compound, and if you had one of those, what would the mass be? It's also known as a molecular mass, the mass of a molecule, or a molecular weight. And all you do is you take the masses of each of the atoms that are in that unit and you add them together. So the whole equals the sum of the parts, right? So the formula mass is going to be the number of the first element, the number of atoms, times the mass of those atoms, average mass. And then you add how many of the second element times the mass of the second element. And you just keep going for how many you have. So let's calculate the formula mass of calcium nitrate. What do we need first? We need the formula. Yeah, all right, so we're sneaking in some nomenclature practice here. Ionic, molecular, or acid? So I hear ionic and molecular. Calcium. Is calcium a metal? Yes. So it must be ionic. That's okay. So what's the charge on a calcium ion? 2 plus. And what's the charge on a nitrate ion? -1. Right? So then our formula is CaNO3, 2. 2 nitrates for every 1 calcium. Now that we have the formula, we can calculate the formula mass. So we have 1 calcium in this formula, and the average mass of calcium is 40.08 atomic mass units. How many nitrogens are there? 2. Because we have 2 nitrate units. Each nitrate has 1 nitrogen. 2 times the average mass of nitrogen. And how many oxygens? 6. 6 oxygens times the average mass of an oxygen atom. So then you just get out your calculator. 40.08 plus 2 times 14.01 plus 3, no, not 3, 6. 6 times 16. 164.1 AMU is what my calculator is showing me.
Okay.
Yes?
Like, online when we're doing the homework and stuff, I'll use the yellow sheet
Mm-hmm.
for all these, and it keeps telling me I'm having error. Like, it doesn't tell me I'm wrong, but it always gives me a...
Is it fussing about
that
sig
I'm
figs
wrong.
with you?
Yeah, and I think it has something to do with, like, with the numbers I'm using for the weights.
Okay. So what I've done here, because I happen to have memorized these because I use them all the time, I just remember the 4 sig fig atomic masses of a bunch of the elements. And so it's a lot faster for me to just do that instead of turn around and look at the periodic table for each single one. So this is the minimum that you should do, is 4 significant figures. Never round to less than 4 sig figs, because that's going to cause problems. But you are very welcome to include all the sig figs on whatever periodic table you have in front of you. The slight differences in them should not cause a problem in your final answer. Now, if Mastering Chemistry is fussing at you, it could be that you're discounting that there's something else in the calculation that is limiting the significant figures, and you're just reporting too many. Or sometimes Mastering Chemistry is just really pissy.
What was the reasoning for putting the 2 in?
Oh, this 2?
Yeah.
Okay, so when I look at these, this is a +2 charge and this is a -1 charge.
Oh, 'cause you did 2.
Yeah, so I need 2. Yep. Any other questions? We could argue about whether this number should have 2 decimal places or not, and I don't want to argue about that stuff. I could argue it both ways. in the problems that we're going to be doing, it's usually not the formula mass that is limiting the number of significant figures. And so what I usually do is I just use whatever my calculator shows me. I don't round it at all, because at most I'm getting 1 or 2 extra digits. It's just not a problem. And then usually it's something else, like the starting mass or something else in the problem is going to limit it to 3 sig figs or something.
Yeah.
So we don't have to fuss about sig figs and formula masses. Just do not round atomic masses to fewer than 4 sig figs. Okay, so that's a formula mass. What's the molar mass? The molar mass of a compound is the mass of 1 mole of the compound. Just like the molar mass of an element is the mass of 1 mole of the element. So it's the same number as the formula mass, but the unit is different. It's grams instead of atomic mass units. So what's the molar mass of ammonia? Well, we need the formula, right? What's the formula for ammonia? NH3. It's actually on the board. It's not labeled, but. So the formula is ammonia is NH3 because we memorize it. So now we're going to take, we've got 1 nitrogen, and I'll show you this with all the units in here. In 1 mole of this compound, I have 1 mole of nitrogen. So 1 mole of nitrogen times 14.01 grams of nitrogen per mole of nitrogen, right? And plus, I have 3 moles of hydrogen, and each mole of hydrogen weighs 1.008 grams.
Denominator 3 or 1 for hydrogen?
The denominator is 1, because 1 mole of hydrogen weighs 1 gram. And so I think this comes out to 7.034. Anybody do it? I've done it so many times. My only problem with the molar mass of ammonia is sometimes I switch the 3 and the 4. Did I do it correctly?
I don't know.
Somebody got, I don't know. Okay, I'll do it. 14.01 plus 3 times 1. I have to do everything. I got it right. 17.034 grams.
I bet you say that a lot at home.
I do. Don't I have to do everything? Sitting around all day while I'm at work, and I come home and they can't even wash the dishes. Don't get me started. So this mass, right? That is the mass of 1 mole. So a lot of times when we talk about a molar mass, we'll say it's 17.034 grams per mole. Because 1 mole of NH3 weighs 17.034 grams. We can use the molar mass of a compound just like we use molar masses of elements, but now we're not counting atoms, we're counting molecules. And so the big picture here is you take a mass of your compound, you convert it to moles using the molar mass, and then you convert it to the number of molecules using Avogadro's number. So find the number of ibuprofen molecules in a tablet containing 200.0 milligrams of ibuprofen, and there the formula is given to you because there's no way I would expect you to know that. I don't even remember it. And ibuprofen is my favorite medicine. It's the answer for everything. Sprained your ankle playing football? Take some ibuprofen. You've got a headache because you've been doing calculus? Take some ibuprofen. Fixes everything. Yeah. Yeah. Okay, so we have the formula given to us, but we're just going to approach this as dimensional analysis. We're going to look at what numbers were given in the problem and what we're trying to find. So we were given 200.0 milligrams of ibuprofen. And what are we trying to find? The number of molecules. So then how do we get from milligrams to molecules? Well, moles are in the middle, right? So we're going to put moles in here. Because going from moles to molecules is Avogadro's number. Milligrams, what's the missing unit between that and moles? Grams. We need to get grams in here, so we'll go milligrams to grams, grams to moles, moles to molecules. So I'm going to have grams, I'm going to have moles, I'm going to have molecules. So what we learned, what was that, chapter 1? Just units. Put the units in there. After all the units are worked out, then that tells us where to put our numbers. So over here, the number of molecules in a mole, that's Avogadro's number. The mole is a dozen, chemist's dozen. So there's 1 mole, and the number goes with the particles. It's really inconvenient for writing all of this out because you've got this long number with the long word and a short number with a short word.
Inconvenient to have to write out molecules.
It's very inconvenient to write out molecules. That's why I think molecules should have an abbreviation. Moles really doesn't need an abbreviation.
One more letter.
But, you know, they didn't ask me about this. This one's also easy, doesn't require any calculating. We know that milli means 10 to the minus 3. So we've got milli in the bottom. We're going to put what it means on top. 10 to the minus 3. So 1 times 10 to the minus 3 grams is 1 milligram. And then here in the middle, how many grams per mole for this compound? We have to calculate this. So this time I'm not going to put any units in my calculation. Whenever you calculate a molar mass, this is what I think you should write down, just, on the edge somewhere. So we've got 13 carbons, 13 times 12.01, plus 18 hydrogens times 1.008, plus 2 oxygens times 16.00. Because sometimes we have a brain fart and we write down the molar mass for calcium instead of carbon. Or we just copy a number down or do something else dumb. Or we wrote it all out correctly, but we screwed up when we put it in the calculator. By having this written out, we can find the mistake and get rid of it a lot faster than if you just are chunking things into your calculator without writing anything down. I don't even know what that button does, and I keep pressing it. So my calculator is giving me 206.274. Is that what you got?
Yep.
Cool. Now, if you used more digits, you might have a little bit of variation at the end, but that's not going to be a problem. So I did all this without units. A molar mass, that means it's this many grams per mole for that compound. Okay? So that number always goes with grams. So we're going to put that in the denominator. 206.274 grams is equal to 1 mole of ibuprofen. So 200 times 1 EE negative 3 divided by 206.274 times 6.022 EE 23 equals. How many significant figures is this answer supposed to have? 4. Our starting mass had 4. Avogadro's number, as we've written it, has 4. Our molar mass has at least 4. And then this is exact. So 5.838. There's 4 sig figs. Write down 2 extras just because I told you to. And then don't forget the times 10 to the 20th. That's really, really important. And so then we get 5.839 times 10 to the 20th molecules. Any questions?
Yeah, I do have a question. It's not regarding this.
Okay.
Okay. Yesterday I was reading an article about graphene.
Mm-hmm.
What's the difference between like the atoms, how they're bonding to one another versus like regular another something
Like graphite?
Yeah, like graphite or diamond. Or
Okay, so that's an excellent question. What's the difference between graphene and graphite? Why are they so different? We actually cover that, I think it's in chapter 12. But we can peek ahead during lab if you'd like. Yeah, graphene is really, really cool stuff. Any other questions?